Hi, I am Mali, and welcome to the channel. IP adapter allows you to generate an output based on the source. You can control your subject position using attention masking, or blend multiple subjects and the environment to generate a single composure. By using conditioning combine, you can create multiple variations from a source. And by adding mask conditioning, you can manipulate the subject further. Let me show my hacks and the different IP adapter workflows in ComfyUI. A big shout out to the channel members for their continued support. This tutorial includes multiple workflows. All of them are available via members-only posts on YouTube. This is a basic tutorial. However, Comfy know-how is required. If you are new to Stable Diffusion, check out the video in the description. It explains the basics of Comfy. Comfy Manager has to be manually installed. Go to the manager and install the ComfyUI IP Adapter Plus node. Also, install the ComfyUI Essentials. From the Install Models tab, search for ClipVision and install both the IP adapter models. It's recommended to download the models directly from the manager, as the models get downloaded in the appropriate folder. For the IP adapter models, go to the Hugging Face page. Download all the .safe tensors files within both folders. Place them in your ComfyUI Models IP Adapter folder. Click on Load Default. This will load the basic workflow. Search and add the IP Adapter Apply node and a Load Image node. Drag from the IP adapter inputs and add the following nodes. I am using an SDXL checkpoint called Juggernaut XL. For now, choose the base SDXL model for both. Later in the tutorial, I will explain which models match each other. To organize your saved files, right-click and convert file name to input. Connect it with a primitive node. By doing this, you can make Comfy to create subfolders in your output folder and save files there. The code is given in the description. Ensure that the empty latent resolution matches the Stable Diffusion version. A simple prompt that includes cute kitten and Christmas. Let's cue prompt. The reference image here gets encoded by the ClipVision model. This encoder resizes the input image to 224 resolution and crops it in the center. Now, if you use any image where the subject is not in the center, you will get an undesired result. This won't affect the current image as the cats are in the center. However, it changes the environment slightly. To avoid this, add a node called Prepare Image for ClipVision, which will do all these operations for you, and you can see the preview of the cropped image. Let's say you take a very long image. Without this node, the clip engine would get the following image. With this node, you can set the crop position to top and get the subject face centered. If the image is too blurry, try using the sharpening tool. The image on the left is without the node. As said earlier, since the source image is a 1:1 ratio, it did not affect the main subjects. There are minor differences in the background. Keep this in mind when using IP adapter. These two image encoders must be paired with the correct IP adapter model. Typically, you pair the model with the matching clip vision. However, only the base SDXL model works with the matching clip vision. To run any other SDXL model, you should use the SD 1.5 clip vision. When pairing non-SDXL models, all will work with SD 1.5 clip vision except this one. To use this IP adapter, you should pair it with an SDXL version of clip vision. Any mismatch in the pairing will give you the following error. So, keep this in mind when using IP adapters. I am duplicating the nodes 5 times. This way, we can compare the cropping method results in the prep image for the clip vision node. The cropping method you choose in the node affects the generation. For the tutorial, I used the first Lanczos method for cropping. I find it the best. Nearest is the worst. Bilinear is better than nearest. However, it is still blurry. Box is mainly used for downscaling. The contrast and details are less when compared to Lanczos. Hamming offers a balance between details and smoothness. Bicubic is the second best out of the lot. IP adapter has 3 weight types: original, linear, and channel penalty. These are at strength 0.6. Original is very strong. Channel penalty, on the other hand, is too sharp. Notice the sharpness around the ears. The prompt says cute kitten. If I increase the strength to 1, then we get 2 kittens for linear. However, at 0.6 strength linear leans more towards the prompt. I found this evident as well while using masking combine. Whenever you want the model to give more weight to the prompt, reduce the image weight and choose linear. Later in the tutorial, I will show you a practical example of choosing linear over original. The source image I used is a square and contains 2 subjects. I often stumble upon the AI creating additional or distorted subjects when going very wide or too tall. Let's pick a wider aspect ratio and see what happens. Okay, 3 cats. Let's try some tall ratios as well. This one is fine. Let's go even taller. Yup, this is elongated. These distortions can be fixed with attention masking. Duplicate the load image node. I am copying the output just for the ratio. The image does not matter, as I only connect the mask output to IP adapter. The reason why multiple subjects are created is because there is no confinement. What I will do here is just make a small, rough mask. The AI will try to generate the 2 kittens within this space. Cute. Let me edit the mask again. I will try to expand the mask as much as possible towards the edges of the visible cat. Let's see what happens when I do that. Even though the mask was a rectangle, it generated only 2 cats, and now I can see more of the original image in the background. So, a wider mask area gave the AI more room to integrate the other elements from the source image. It would be interesting to see what happens if I take the original image, and in-paint both the cats as a mask. I don't know why I am drawing so perfectly. Basically, you can do anything rough. So, it changed the perspective a little. Let's try the linear weight type. And it did nothing. I guess it's because the weight is still 1. I will revert to the original for now, and only reduce the weight to see what it does. Okay, let's stick with this. I want to try and manipulate the position of the subject. I will copy this ultra-wide image again. It makes it easier to define the position. Let's try left. Only 1 cat? Wait a second. It's probably because of the weight. That's better. Let's try masking them on the right. Making the mask a bit wider. Cute. Again, it got the elements from the background and included in the generation. Now, I want to see what it does if I create 2 separate masks. Let's do right and left with some gap in the center, to really separate them. This should be interesting. Nice. Did not expect that. Cool trick, huh? The goal here is to try and blend 2 subjects with an environment. Aesthetics is not essential, but I would like to see what works and to what level I have control. I will quickly duplicate the IP adapter nodes. When you have 2 or more IP adapters, the checkpoint connects to the first, and the K-sampler connects to the last IP adapter node. You then daisy chain all the IP adapters in between. I will try blending the cat and the dog in one image before adding the environment. I added dog in the prompt. The control weight being 1, I got a hybrid of a dog and a cat. I will not add any noise here, but just reduce the weight to half for each. That did something. But it looks like the first weight is way more than 50%. Both of them don't seem to be equal. Let's add some noise and see if that makes any difference. Technically, it should not. The dog is now in the background, and it makes it worse. Let's try color masking. Here, I will use Load Image Mask. The image mask allows me to define the channel. I will explain that in a bit. So, here you choose 3 colors, that is red, green, and blue. What color is for what doesn't matter. I have taken blue as a background. I will define the subjects as red or green. One thing you should take note of is that the color code for this should be pure blue, green, and red. Any color variation will not work. This can be created in Paint, Photoshop, or any graphic editing tool you have. The drawing has to be a rough estimate. I'll set the cat as red and the dog as green and cue prompt. The outcome is as expected. However, you have to be careful here with the order of the flow. Let me explain. The cat image is connected with the first IP adapter. The dog with the second. Similarly, red is on the left, and green is on the right. The prompt says cute kitten and dog. In all 3 places, the cat is first, and then the dog. Changing the order partially will result in undesired results. When using multi-IP adapters with masking, the sequence directly affects the output. The order of the inputs, like the mask, image, prompt, and IP adapter nodes, matters. To explain this, let's say I change the prompt to say cute dog and kitten. I don't change anything else. Check out the result. Just changing the prompt order generated a dog-cat hybrid. Let me revert the prompt back and change the color mask order. Mind you, the mask is still connected to the correct IP adapters. A different image, but still a hybrid. Why does this happen? The model processes the image from left to right because the nodes are connected linearly. In the mask, the red is on the left. Since both masks are connected to the IP adapters, the model assumes red to whatever is given in the first image and prompt. Keep this in mind when using multi-IP adapters. To get a more coherent output, let's end the first IP adapter at 40% of the steps and start the second one from there. Perfect. Now, I will add a third IP adapter, and this time, I want to take elements from a scene and try to influence the output. The more IP adapters you add, the more difficult it becomes to balance them out. The channel here will be blue for the background. Let's end the first at 30% of the steps. Second at 70. And reduce the weight by 0.10. Minimal difference. There are stars in the carpet, however, it is neglectable in the output. Let's try adding bed to the prompt. Okay, let's change it to besides bed. The stars are somehow more prominent. I tried other prompts and settings, but this is the best I could get while keeping the two subjects more or less consistent. In this workflow, I will disconnect the IP adapter nodes and generate an image based on a prompt. Connect the VAE decode output directly to the IP adapter node. Add another K-sampler and connect the relevant inputs. From this second K-sampler, I will generate 4 outputs for variation. Let's control the cat posture by adding ControlNet. I am adding a simple ControlNet apply, along with an all-in-one preprocessor node. Connect the positive conditioning. I am using a Control LoRa open pose model. And for the preprocessor, we will use the animal pose. This is how the animal pose looks like. Connect to the sampler and cue prompt. IP adapter does burn the image. The solution is to lower the guidance value or reduce the adapter weight. Duplicate the positive prompt. Wearing a cowboy hat. I will combine the prompt and the ControlNet via conditioning combine. This is not that good. Let's add a depth ControlNet and see if that makes any difference. Way better. Let's move on to the last workflow. In this workflow, I will show you how to use mask conditioning. Let's generate a cat wearing a cloak. Let's try to change the cloak's color to pink via prompt first. That did not work at all. Add a load mask image. Paint over the cloak area of the cat and add a conditioning set mask node. When you set the conditioning area to mask bounds, it will only apply the condition within the masked area. The default applies it throughout the image. There are not enough pink cloaks. Let's increase strength to 4. And this would be an excellent example for switching the weight type to linear. Excellent. One last thing left to do. Now, I want to add a beanie hat to the cat. There are 2 ways to do this. The first method is to edit the mask and the prompt for the existing workflow and add a beanie hat. I was not happy with the results for this one. So, I am going to show you the second method. For the second method, duplicate the mask conditioning and the conditioning combine nodes. Connect and queue prompt. Having 2 mask conditioning in a conditioning combine caused some errors in the generation. There is an easy fix. For the beanie mask conditioning, set the conditioning area to default. Let the first cloak one remain to mask bounds only. I hope the tutorial was helpful and you learned something new in ComfyUI. Until next time.